EE271 Signal Processing Lab. Our team members are Stephen, Alistair, Daniel and Emma. The aim of this lab is to design, construct and test an ultrasonic measuring device to find defects. An ultrasonic measuring device works by the transmitter sending a signal which is reflected off either the back wall of the block or a defect. The reflected signal is detected by the receiver. The time taken for this to happen enables the distance to be calculated.
The pulse generator portion generates a regular square wave. The frequency is dictated by the capacitor and resistor ratio. A low frequency is imperative as there must be sufficient time for the previous ultrasonic pulse to die away. The signal is differentiated to give narrow spikes. A diode is used to remove the negative voltage component. A transistor and op-amp could have been used to achieve the same result. At this point, the output is forked with the remaining signal delayed. This slightly later pulse is fed to transducer trigger and starts the timer.
Once signal returns, it enters the receiver. The receiver's purpose is to first amplify the signal, then condition the signal, converting it into a fast rising and falling edge TTL analog pulse. Finally, the signal is fed through a comparator to achieve a digital waveform. This waveform is used to trigger the stop signal of the clock on the measuring device. For this project, we decided to utilize a simple design passive rectifier that results in less potential errors. For amplification of the signal amplified, but if the voltage and current are amplified separately, they are then fed into the rectifier part of the circuit that consists of a germanium diode to convert the signal to a positive going waveform. The wave is then bypassed into a resistor and capacitor in parallel configuration, which converts it into a digital waveform needed for the measuring device.
This diagram shows a high-level design of the final circuit. The final circuit was constructed such that the transmitter sends a trigger pulse to the transducer. The transducer sends the amplified signal through the test piece, and at the same time the counter is started. The signal travels through the test piece, bounces off the back wall and back to the transducer. When the signal is received, the counter stops and the display shows the thickness of the test piece. This thickness is calculated using the operating frequency of the clock and the speed of sound through the material. This distance was validated using a ruler.